Which operators, ma? Bitwise operators we will go. Operators is going on. So last session we have done it. Logical operators we did. Logical operators we have done it. Okay. So there we learned it. What is an AND operator? What is an AND operator? It's a truth table. What is example? OR operator and its example, and a short circuit evaluation with OR operator, and short circuit evaluation in the case of AND operator. We have completed that. Okay. Later we entered into the NOT operator also, which is just opposite to what? AND and OR. Next, later we gone for certain examples on NOT operator, how it is going to be. So that is already we discussed in the classes. Okay. So now it is the time to see, to go for the another operators. Let me open operators in Python once. There we completed the first 4. Now I'm going to enter into the most important. That is what operators? Bitwise operators we are going to discuss. It's an important, guys. So written test point of view, this is very important. These operators are. Yeah. So let us start with what exactly bitwise operators are. So bitwise operators, first of all, let me start the discussion. You have already seen in C language, C++, different programming languages you might be experienced with. But all those things, you at this present, I can say that nobody knows what is the importance of this and how they are operating internally. What is the purpose of these? We are not aware of it. And especially as a part of my Python class, what I am explaining, you apply for other programming languages also, same thing as what I am explaining in the class. Okay, right. So bitwise operators, what we are discussing now, is common in other languages also. Okay, like in arithmetic operator, if you go for a double star, is not there in C, is not there in C, is not there in CPP, is not there in Java, is not there in .NET. It was not there in .NET. It was there only in Python language. So some special operators may be there. So bitwise operators concept is going to be same in most all the programming languages. Okay, students. Come on, let us start the discussion here. What exactly these bitwise operators are? Very simple. Look at that. Bitwise operators are applied. Bitwise operators are applicable. First of all, let me read this point. Bitwise operators are applicable on integer data only. Integer data only. But not applicable on floating point values. Floating point values. The biggest question will come, sir, why? Why this is not applicable at the floating point values? And in any programming language, this is going to be the same, because all the programming language developers applied the bitwise operators only on integer data. Let us go to the testing environment for a minute. Go to the Python 3.10. Suppose if I say A is equal to 10, I can print A as what? 10 itself is 10 only. Then 10 itself is 10 only. 10 is not 9.99999, it is not. Are you getting? Suppose 3.14 you take it. Some B is equal to 3.14. It is printing B is equal to 3.14 only, no doubt in that. But internally 3.14 is not 3.14. How, sir? How can you prove it, sir? And we already had one small discussion in our class. Percentage 0, you know, percentage of format specifiers, beginning print statement level I set. So I'm writing 0.25 F I am writing. And that means after the dot, I am expecting 25 decimal places. Why I'm saying is, 3.14, when I say dot 14, it is not just 14. It is going to contain lot of internal digits. Floating point values are not fixed only with 2 digits. It contains some number of digits internally. That's why they are not finite value. It cannot give. It won't give the finite values directly. So when I print it, you see students, after that 1.14, after that lot of other digits are also there. You see, I will write 30. I will write something like, 35, I will write it. See students, it is containing some digits are there. You see other place, I will write something like a 40. I will write 40. I will have 40. See that I have some digits after that. So is it 3.14 as 3.14 or it is going to be something else? It is going to be something different. It is not 3.14. Finitely, it is not 3.14. It is not guaranteed that it is 3.14. It is containing 3.14. So many number of decimal places are there. Are you understanding me? So if I come to this A is equal to 10, if I say A is equal to 10, if I print it of A, if I write it, it is going to be 10 only. It is going to be, you print it as what, 55. You 55, you say it is 10 only. There is no variance in the decimal places. That's why bitwise operators applicable only for definite numbers only, not infinite number of decimal places. Did you understand this meaning, ma? So this is the question you will come across. Bitwise operators applicable only on integer data only, but not on but not applicable on, because they are varying in the precision part. I can write it because they are varying in where? They are varying in precision part, I am saying. Precision, do you know precision? Do you know precision? Decimal part. Precision is nothing but decimal part only. They are varying in precision part. Okay, right. Now, in this place, what is happening? Here, bitwise operators, what this will do internally? The purpose of bitwise operators is, I am writing, the purpose of bitwise operators. The purpose of bitwise operators. I'm going to say each operator purpose is there. Overall purpose I'm saying. The purpose of bitwise operators is that converting integer data internally into binary format and performs binary operations in the form of bit by bit. That's why they named us bitwise operators. How the operations are done? Bit by bit. That's why they named as what? Bitwise operations. And hence these operators are named as what operators? Bitwise operators. Of course, I need not write this sentence. Why they named as bitwise operators? I just want to give you the clarity in this case. And hence these operators are named as bitwise operators. Okay, students. Now I'm going to say in Python programming, we have how many bitwise operators? I said 6 bitwise operators are available. What are those? See students. First one I am writing left shift operator. Left shift. I will explain left shift operators. Left shift operator. The symbol for that is like this. Left shift operator. Second is called right shift operator. Right shift operator. Operator name is called 2. That is called right shift operator. Right shift operator. I'm giving like this. Next, I will explain each and everything, guys. Next is called what next I will take it as, I will add the word bitwise left shift, bitwise right shift, bitwise right shift. Next I will write it bitwise bitwise AND operator. Bitwise AND operator. Already we have seen one AND operator. What is that AND operator? Physical ANDing. Physical ANDing deals with what? True or false. Bitwise AND deals with what? Zeros and ones. Because I told you already in this place. Everything will be done on the basis of what? Bit by bit. Bitwise AND operator. Bitwise, if you read, because I don't know, some number of months back, bitwise AND operator. If they are asking where is an operator, you are most intelligent student. Don't get the doubt. First of all, I wrote in English because actually I should not raise this. Because our student will be concentrating, I just want to test. Bitwise AND operator. It is nothing but operator name. He is calling bitwise one word, operator is one word, separated with AND is thinking. So it's not a separate word. Bitwise AND operator. What is the symbol name? I am using here like this. Next is called bitwise OR operator. Bitwise OR operator. This is called fourth. Bitwise OR operator. This is called OR operator. Now I'm writing like this. Next is called what you know. Fifth one I will write it. That is, sorry, bitwise complement operator. Bitwise complement operator. Complement operator. That is called operator name is a tilde operator. Tilde. Okay. Last and final, bitwise XOR operator. Bitwise XOR operator. That is called a symbol like a cap symbol like this. So, of course, I am not boasting about my class. You take any student and ask these operators. They don't know how they works. But I will give you complete meaning of how these operators will work. One by one, I will explain. Shall we start now? Why do you use bitwise operators? How the bitwise operators are working? The purpose of bitwise operators is that converting the integer data internally into what format? Binary format, and performs binary operations in the form of bit by bit, and hence these operators are named as bitwise operators. So internally, how the operations are going on? Binary operation. That means which function they are using internally? Bin function they are using. Bin of, hex of, oct of. Already explained or not? And finally, I can give that. And finally, final result always displayed in the form of decimal number system. Decimal number system is a default number system or not? Decimal number system is a default number system. Yes. So performs the operations bit by bit, and final result always displayed in the form of decimal number system. Hence, these operators, since the operations are doing bit by bit, if you want, I can write this next line because it's not necessary, but I want to write it. Since the operations are carrying out in the form of what? Bit by bit, and hence named as what? These operators are named as what? Come on. These operators are named as what? Bitwise operators we can call. How many bitwise operators we have? 6 bitwise operators are there. Let us start with the bitwise operators in the class. So let us start with the bitwise operators. This I will take it. So dear students, every operator from the beginning onwards you are seeing, we are talking about where we can use in real-time projects. And at this stage, first 2 operators, I will tell you how they works. Where I will use it, I will tell you in the next examples. I will tell you in every batch, first 2 things, I will tell you how they operates. Later, I will tell you where I can use it. Are you following me? First, I am saying how they are operating internally. Later, I will tell you where I can use it. Okay, na? Suppose, for example, here just for a minute, I will just share one general example. Suppose this is called one chair, ma. This is called another chair. This is called another chair. Like this, I have some number of chairs are there. How many people are how many people are sitting here? All these people are sitting here. These people are sitting here. All these people are sitting in this place, right? Now, these people are sitting here. Fine. Now, some other people came. Some other people came to sit in the same place. How they need to sit? Where they need to sit? Definitely, they completed their time of sitting. Other people are waiting to sit in the same place. So I need to shift them or not? I need to shift them. How they will? How I can shift it? Either to which side I can shift. Either to right side I can shift, or I can shift to where? Either I can shift to left side, or I can shift to what? Right side. In application point of view, I will tell you what is the need of shifting. In normal life, suppose you are sitting now, your time is over. Other people will start sitting and you will be shifted outside or not. Like that, I am telling in the application part of it, where I can use it. Today, I am telling about how they are operating, how they are working internally. I will tell you. Next, in the examples part, I will take care. In certain point of time, I will use this operator only very perfectly. So that time you can understand its purpose. Today, I am telling only internal operation of internal working of what? Bitwise operator, left shift operator, I am going to say. One or two operators I will tell like that. Later I will tell you the another purpose, I will tell you other operators in the class only. Yeah. So syntax I will take it now. Syntax I am going to give you. What is the syntax name here? Variable name is equal to variable name is equal to variable name is equal to I am writing given data. Some data will be given. What data will be given? Integer data will be given definitely. Integer data. I am writing left shift operator name is called left shift number of bits. Number of bits to shift. Number of bits to shift. Number of bits to shift. Are you getting my point? Yes. Number of bits to shift. We are going to start. Students in the online, are you comfortable, ma'am? Are you able to understand this? This wording is okay? Because I did not talk to you. Is it okay? Is this comfortable? Yeah. So let me go to the discussion here. How this is operating, I am just going to talk. Dear students, I will write the concept. How it is working, I will write in the form of one sentence, I will write it. Let us coming to this same mechanism, I will go to paintbrush, because there I will explain some colorful output for you. Just for a minute, you watch it. So this is going to be having like this. This is called a given data. This is called my given data. Syntax and all those things are available. Now I am saying this you leave it. This you leave it. Now I am going to take it. How they are operating. Now I am going to give you the clarity like this. N is equal to my Python command prompt. Some N is equal to or some A is equal to something like 10. 10. What is the binary format of 10? 1010. 1010 is the binary format of 10. I told you how to do that 10 into binary. I told already in the class. Conversion chart also I explained. 2 5 ja 0, 2 2 ja 4. It is called 1. 2 1 ja, it is called 0. So it is going to be taken as what? 1010. We discussed this. Okay. So this 1010 is a value which you are getting it, no doubt in that. And this is a result we got it. Perfect. My dear students, how many bits are there? 4. There is no hurry, understand perfectly. Next, before that also, I can say like this also I can write or not. And I can't say that for every binary number is only 4 bits. It may be 6 bits also, it may be 7 bits also, it may be 8 bits also, it may be 16 bits also. Understand? How many bits representation? Come on. 4. See, 8 bits are there. How many actual value is taking how many bits? More than 10, more than 25, some 100 is coming. Is 100 is taking only 4 bits or more than 4 bits? Definitely it is going to be next time writing one more. What is this is called? 12 bits. Next time I'm going to take it as what? 16 bits. Next I'm going to take it as what? Right. Next I'm going to write like this. It is going to be taken as what? This is called my number. I can say my number like this. I can represent our binary number depends on your registers. How many number of registers we started our computing? 8-bit register, 16-bit register, 32-bit register, 64-bit register. Did you understand that? Now I am representing my number. I am representing my number 10 on 16-bit number, 16-bit register. Okay, see how I am going to represent. Actually, students, this is going to be dead easy, but student will feel very difficulty. Nothing is there in this 16-bit register I am taking. 16-bit registers means how many partitions? How many partitions can you understand, my dear students? One. This is called another one. This is called another one. Did you understand, students? Very good. Now, dear students, try to understand me, ma. All of you try to understand. Just try to understand. I will bring it. Let it be. That is called a syntax. Here I am going to write it. The data is 0, 0, 0, 0. Same thing. It is going to be coming 0, 0, 0. And next is what? 0. Next is going to be 0, 0, 0, 0. Of course, it is going to be like this. So, coming to the point of it, this is the data what we have. Next I am going to write it what? 1, 0, 1, 0. This is my data what we have, right? Right, good. This is my data what we have. This is called what bit computer? Come on, mom. 16-bit register. 16-bit register. Okay, fine. What is this value called? A value it is called A. This is representing what value? A value it is representing. This is representing A value. I will just try to write it. I'll just try to write it. Because one thing if you understand carefully, other things are dead easy. Not at all difficult for you. First one thing you need to understand carefully. Okay. Now I'm going to say this is a value pointing to this. This is a value pointing to this. Okay, good. Now I'm writing next students, you observe it. Here I'm writing some result is equal to, some RES is equal to, I'm saying A given data, I'm writing just 2 I'm writing. 2, I'm writing 3 for example if you take it. What is 3? Number of, see that, always my syntax will give you very, very easiest way to you. Number of bits to move, which side? Left side. At this point of time, don't ask me, sir, why to move left side? I will explain, I said. I will explain why to move left side, why to move right side. I have a beautiful examples for it. You only will say, sir, move left side and move right side. Why to move left and right side? I will tell you. At this point of time, operator left shift says shift to specified number of bits towards left side. Even symbol also, you don't remember. Symbol says which side is moving, which side the direction is moving, left side. Okay, whenever you say this sentence, my dear students, and try to understand me, ma. Okay, I just wrote some close to it. Then I will write this statement. Whenever you are getting this line, do you know the same kind of diagram? I will carry this. I will take this diagram, right? And don't get tension for it. First, try to understand. I will get this number as it is. This place, whatever you have, in that place, what this diagram says? Move how many bits towards left? 3 bits. 3 bits moving left means what? Remove 3 bits left side. Simple. All chairs are filled. 3 students are supposed to accommodate. Already you people came in the morning only. Which students they are sitting on the basis of first come, first served. So already the people who sat beginning onwards, I need to give the chairs for latest students or not? What I will do, the students who came very first, I will shift to 3 bits outside. 3 bits outside means no more chairs, I will remove them. And I will accommodate the room for newly arrived people, because it is used in the operating system level concepts. I'll explain that, nothing to worry. What is happening, ma? 3 bits are taking away, flipping off. Flipping off means taking out. How many bits? Because you specified how many number of bits? 3 bits. So just I'm writing flipping off. Once you say flipping off, what is happening? What is happening there? So 3 bits are flipping off. 3 bits are flipping off. That time, what is happening? 3 bits are flipping off. Once 3 bits are moving, these bits are moving which side? Left side. Once if I remove 3 bits left side, just imagine the diagram how it is available. Just imagine the diagram how it is available. Just imagine. So what is happening? 3 bits are shifting to that side. It is nothing but what is available. This is, these bits are removing. These bits are removing. 4 bits are there totally. Here what is available, ma? What is available here? 0 is available. That is nothing but here 0 is available. How many spaces are there? Three spaces are available. Like this, 3 spaces are available. Here 1 space, here 1 space, here 1 space. 3 spaces are available. 3 spaces are available. 3 spaces means what is happening? Just imagine this will come to this, this will come to this place, and this will come to this place. This will come to this place. All of them are moving to left side or not? Tell me. Once if you understand me, once you understand me, what is the bit configuration is available, I just want to ask you quickly to write it. Tell me how the numbers are available here. 0, come on, 0, 0, 0. Actually, these 3 zeros are coming from the next box. If I do this, what is happening? I just want to give you the clarity here. I just want to give you the clarity here. So understand me, my dear students, it is going to contain, if you really follow me, it is going to contain here. Come on. 1, 0. Very good. 1, 0, 1. And the next is called what here? Very good. 0. Actually, that's it. How many spaces are there here? 3 spaces are there. This is 1 space. This is 1 space. This is 1 space. And this is 1 space. Because how many bits you are moving? 3 bits you are moving. When you are moving 3 bits means 3 spaces will be there or not? What our PVM will do is, our PVM will place what value? Since it is an empty, what will be placed? Zeros will be placed. Don't ask me, sir, why 1 is not placing? 0 means no value, no? So empty means no value. Empty means no value. It is placing 0 there. Did you understand? Now tell me now. This is the RES is pointing here. RES is a variable which is pointing here. If I print RES, do you know what is the result is coming? This result is going to be given as like this. Look at that result. What is this result is called? Binary format or not? Come on. What is this now? 2 to the power of what? 0. Come on. 2 to the power of 1. 2 to the power of 2. 2 to the power of 3. Come on, ma. 2 to the power of 4. 2 to the power of 5. 2 to the power of what? 6. What is that 2 to the power of 6? 1 into 2 to the power of 6. What is this result? 1. 1 into 2 to the power of 6 is called 1, my dear students. So dangerous. 1 into 2 to the power of 6, how much? 2 into 2 into 2 into 6 times was 64. 64 plus 0 into 2 to the power of 5. 0. 0 into 2 to the power of 5. 0. 1 into 2 to the power of 4. 16. 1 into 2 to the power of 4. 16. 16. And the next 0 into 2 cube, 0 into 2 square, 0 into 2 to the power of 1, 0 into everything is what? Now what is supposed to add? 2 to the power of 4 and next is what? 2 to the, that is 64 and what? What is the result? 80 is the result. Are you following? So 80 is the result. If you don't know mathematics, I can't do anything, ma. So mathematics, this course is not mathematics related. This is called what? 80. 80 is an answer. Let us go to the Python environment immediately. A is equal to 10. Something like RES is equal to A double less than 3. Print of RES. Print of RES. 80 is an answer. 80 is an answer. I will give you one beautiful formula. This is the biggest shifting the bits and everything taken or not? Shifting the bits, everything has taken it. Now, if you want to know the formula, I can give the formula like this. What is the formula? See that formula for, of course, this is for only for written test point of view apply. When you apply the formula, even in interview also, they will ask you, explain in detail with a bit shifting. You have to explain the diagram like this. For writing MCQs or any written test, doing this entire thing will take 1 or 2 minutes now to do that. Formula for bitwise, which operator? Left shift operator. Left shift operator is left shift operator. I will write the symbol, ma. Left shift operator is like this. What is that? Result is equal to given data, that is given data into 2 to the power of number of bits. So space is not suitable for me. No problem. I will just cut this. Space is not suitable for me, ma. Just give me a 2 minutes time. I'll go to this place. I'll take this. I'll take this. I'll paste it. So I'm saying 2 to the power of number of bits. 2 to the power of what? Number of bits. 2 to the power of number of bits. I will just take up 2 to the power of number of bits. 2 to the power of number of bits. Look at that. Now you take it example. RES is equal to 10 double less than what? 3. What is 10? Given data or not? Come on, calculate immediately. RES is equal to formula, you go 10 into 2 to the power of 2. What is that 2? Binary bits always 2. Number of bits moving how many? 3. How much is the result? 10 into 8. That is equal to what? Answer is like this. Go to the program now. Directly I will write it. Print 24 into 2. 24 left shift of 2. My dear students, how dangerous you are. 2 into 2 square. 24 into 2, 4. Even multiplications also feeling very lazy. So the answer is like this, right? For you, I have to ask you very simple questions. What is an answer now? This is also very difficult. 2 into 2 square. So it is going to be what? 4. Ayyo. Very dangerous. Maybe totally out of order. So this is called a 12 into 3. 12 into 3. 12 into 2 to the power of 3. 8. 12 8 there. Don't know. Right? So like this. Now say like this I will write it. You take it as 5 into what? 4. How much? 5 into 2 to the power of 4. 16 into 5. Result is like this. Easy? Yes. So not a difficult. What I said is, if you don't know mathematics, I am not responsible. If you don't know tables, I am not responsible. But subject is important. How the data is going to be done? The concept of bitwise left shift operator is that is that the given data converted into what? Binary, and those bits are shifting towards left. Towards left. How many bits? Towards left, how many? By the specified number of bits. By the specified number of bits moving towards left side. Flipping of number of specified bits towards the left. And right side, what is left out? Right side, what is leaving out? Some spaces are leaving or not? In the spaces, what are filled? What are filled with? Zeros. So I'm writing here the concept of, I will write it here. I'm writing the concept of left shift operator. The concept of bitwise left shift operator says that, come on, shift specified number of bits towards what? Left, by adding number of zeros at which side? Right side. Number of zeros is equal to how many zeros you will add? Number of zeros is equal to number of, double equal to, I am writing number of specified number of bits, right or not? Specified number of bits. I hope you are following. The concept of bitwise left shift operator says that shift specified number of bits towards which side? Left side. The operator itself says that left shift. Specified number of bits left, by adding number of zeros at which side? Right side. How many number of zeros? That is a question mark. Number of zeros double equal to number of specified bits. I'll add this. Number of what? Specified number of bits. At which side? Right side. That is what I said. Zeros at right side. So in the diagram also, if you look at, we did that only. I hope you followed. And the formula also I mentioned here. And for the shortcut purpose, we can go for happily applying this concept. So I hope that example part, if you come back, if you take it, in this case, I will just take this, come to this place. Examples I'm taking. So coming to this area, there I will explain. So here it is going to be 3. You can apply the formula what I said. Happily you can apply this formula. You can see this data. You can see this data here. Are you able to follow? This is called which operator? Which operator this is called? Bitwise left shift. Shall we go for right shift? Yes, easy. Once left shift is understandable, right shift is also going to be dead easy. Okay. So students in the online, are you comfortable? Yes, ma, it is not 1023. It can be any number, I told. It can be any number. Is there any restriction? Any number can be converted binary. So why 1023 only specially? Right? So please don't get the type of doubt. Any number you can take it. So let us coming to the bitwise right shift operator. Just to go for right shift operator, students. Come on to the point of it. What is this? Bitwise right shift operator, I will go for it. Bitwise right shift operator, I will go for it. Right shift operator. Right shift operator I am going for. So moving which side? Come on to the point of it. Right shift operator I am going to use it. Right, given data, right shift operator number of bits. What is this conversion process? The concept of bitwise what? Right shift operator says that shift specified number of bits towards towards right by adding number of zeros at left side. Number of zeros at left side. Number of zeros is equal to number of bits, specified number of bits. Just opposite to that. Let us go to the diagrammatic representation now. Let us coming to this place. I will bring it that the diagram format. This number I will bring it, students. Okay, let us go to this place. Right shift operator kind of syntax I will bring. Later I will bring into this place. So let us watch this now. I will just paste it. I'll just take this. Okay, done. After this, I'm going to give you the clarity on this area. Fine. Come back to this diagram. I will take it. This part I will take it. As it is, I will take it. Try to understand. Fine. You take it instead of writing again the same thing. I'll just take directly like this. Okay. Now I'm saying here my diagram is like this. My diagram is like this. B is equal to RES is equal to what I am doing? A. Double greater than what? 3. Listen, ma. If you want to talk, go outside. Inside the class, no. Any doubt is there? Ask me. I told. Okay. If you talk, others will get disturbance. If you want to talk, go outside. Talk whatever you like. Be there only. Inside the class, no. Doubt is there? Ask me. I said. Okay. Right. So doubt. Right. Come on. RES is equal to A double greater than 3. What is the meaning of this double greater than 3? Moving 3 bits towards the right side. 3 bits right side means what? Flipping. We are just flipping. Let us go to that. I will take this part of it, ma. I will take this part of it. So I will take this part. Okay. Then you bring this digit as this. This is called my given number. Okay. Now what is the things are shifting here? Because of this part, internally what is happening? Shifting operations are going on. 3 things are there. This 0 will be flipped off. This 1 will be flipped off. And this another 0 also will be flipped off. Another 0 also will be flipped off. So these things will be flipped off. These things will be flipped off. So coming to the point of it, I'm saying this, these things are flipped off. Once these things are flipped off, you can imagine those things are removing means what? 3 things are moving, 1 will come to last or not? If you imagine that these 3 things I'm removing, flipping off. Flipping off means what? Removing. This 1 will go to last or not? Yes. So in the next diagram, what I am trying to write is, I will bring that result. Okay. Which diagram I am going to bring it? You see what I am going to bring it. This diagram, I will bring it as it is. Once again, I will bring this diagram. You see how it is available. Once 3 things are flipping off, what is happening? See my diagram here. This is the diagram what we have. In this case, these are flipped off. Once these are removed, means what? These chairs are vacant. This person will go and sit in the last chair or not? This person will go and sit in the last chair. So what is happening here? This is called a 1. Obviously, these zeros will be moving here or not? Just come on, tell me what this is going to contain. 0. Okay, tell me. 0 and 0. Right or not? Yes. This is happening like this. This is happening like that. And what is because of the shifting? What is the last 3 things are having? 0, 0 will be there. 3 spaces are there or not? So only 1 0 is present there. And rest of them are containing spaces only now. Yes. Finally, what is placed there? This is a space. This is a space. And this is a space. This is a space. And one more space. Box is not sufficient. I am writing outside. What will be filled there? Zeros will be filled. Zeros will be filled, man. Nothing is there. Since no value is there means it is a 0. Since no value is there, it is called what? A 0. Understand? Come on, what is this is called ma? RES. RES is pointing to this diagram now. What is the value of this? It is printed the data in the form of decimal number system or not? What is this? 1, 2 to the power of 0, next 2 to the power of 1, next 2 to the power of 2, 2 to the power of 3. I go on writing 2 to the power of 2 to the power of 2 to the power of. What is the first one, please? Come on. 1 into 2 to the power of 0. 1 or 2 na? 1 or 2 na? 1. Good. 1. Now, other things are going to be multiplied with 2 to the power of 1, 2 to the power of 2, etc. It is becoming what only? 0. 0. So coming to the point of it, print what? RES is going to give you what result? 1 is the result. Understand? So what is the formula, sir? There is a formula for this. Simple. Let us go to the formula, and of course you can understand very easily. I say formula for which one? Bitwise, which operator? Right shift operator. Right shift operator is what you know. You see, RES is equal to, or something like RES is equal to, what is my given data? Right shift, what is this? Number of bits. This is your formula, na? How you can take care, sir? Okay, let it be. It's not moving that side. So coming to the point back, number of bits you are taking, number of bits you are taking. Go to this place. Some number of bits you are taking. Okay. Now what is the formula? That is equal to, I am writing arrow. I will give the arrow. That means the formula. RES is equal to, you need to take it as what you know, my dear students. Given data divided by, I am writing this mathematics symbol, divided by 2 to the power of number of bits. 2 to the power of what, ma? Number of bits. 2 to the power of number of bits. So in mathematics, you are applying slash. In Python, you must apply what operator, you know? Double slash operator you need to apply. Are you understanding? Double slash operator. Double slash operator will give you only integer coefficient. Right. Come on to the point. RES is equal to, come on students, 10 of what? 3 ma? 3 na? Come on. What is the answer, please? RES is equal to, you know the answer. Don't wait the time. 10 by 2 to the power of 3 or not? 2 to the power of 3. 2 to the power of 3, which is equal to what? Is equal to 10 slash 8. Of course, this is slash only I need to apply, right or not? Slash only I need to apply. By mistake, I did not write. Slash I wrote. 10 slash 8 means what is that number actually to be taken of what? 8. 8 1 ja 8. What is that? Remainder is what? 2. So it is not going to start a dot, etc. will not take. So answer is called what, ma? 1. Answer is called 1. 1 will be coming. 1.2, 1.3, 1.4 will not come. Understand, huh? Let's go. Let us go to the environment testing level. I say A is equal to 10. A is equal to 10. B is equal to, or C is equal to A double less than 2. A double less than 2 na 3 na? 3. Print of what? C, which is nothing but left shift, that is. Left that is. RES. C is equal to right shift you change. No problem. Carefully observe it. Print of C. Answer is what? 1. Once again. Directly I am writing. Print of 2 I am writing. Why this much time, boss? 12 by which operator? First of all, right shift. 12 by 2 square. 12 by 4. 3. Why you are thinking like anything? Even Rosam also did not think this much when he is developing Python. So take care of that. 3. Don't say signals. Say 1. So when you go to interview and interview is asking like that, if you say like this, problem will come. So answer is called what? 1. So like this, I say something like 4. 4. 4. 0. Why thinking like that? 4 is 0. 12 by 2 to the power of 4. 12 by 16. 16, 0, 0. Remainder is 12. 0. Why mathematics not coming? Huh? No, don't know mathematics. Don't know mathematics? Then that only, na? So, students, yes, see how online students are saying just going like a rocket, going like a bullet, right? The moment I ask a question, ready to answer it. What about you sitting in front of me? Not saying anything, saying signals 1 or 2 like that, like a wicket, like a cricket umpire. First ball, second ball, no ball like that. Come on to the point. Coming to the next. Print of 36, 36, 4. 4. 2. It is a 2. 36 by 2 to the power of 4, 16. 36 by 16. 36 by 2 to the power of 4, how much? 16. No problem. 36, take it. 36 of what? 16. 16 to the 32. That is, it will not be worrying about it. I will take this only. So I hope that it is more clear for you. And regarding this operator. Regarding this operator. Okay. Fine, students. I told both of them, when they ask a detailed explanation, explain through diagram. When they ask through what? When they ask any kind of thing with a shortcut for one line of once MCQs related questions are coming, try to go for these formulas. Will you remember the formulas? When the value is going to left side, when your salary is increasing left side, your salary is increasing. Means product. When it is going to reduce, divided by. Easy mechanism. Easy mechanism. Easy to remember. So coming to this. So this one and going to this, getting this done. Which operator it is? Bitwise right shift. Left shift, right shift is easy or difficult? Dead easy. Coming to next what? Bitwise. Yeah. Bitwise and I am going to introduce. Very simple this is. Let us start. Where I can apply, I will use it. Where I can apply, I can use it. In many of the occasions, we will use in our entire thing. But one of the occasion I will tell in the class. First term. Now see, the functionality of, the first functionality I am explaining. The functionality of bitwise OR operator, bitwise AND operator. Bitwise AND operator is expressed in the following truth table. In the following truth table. What is the truth table I am writing? So look at that. One state is P. Of course, whether you will understand me or not, to make you to understand, I will take like this. Look at, I will take it. One of my input, one of my binary input, I am taking input 1, input 2, input 1, input 2. Now I am applying input 1 and input 2, input 2, input 1 and input 2 I am giving. Carefully follow ma. What are the inputs here? Earlier I have taken true, false, false, true, false, false, true, true. That is Boolean values. Now here they are dealing with what? Binary bits they are dealing with. What are, how many binary bits you have? 2, 0, 1. So what are the combinations to be taken? Tell me. 0, 1. Next what? 1, 0. Next what? 0, 0. 0, 0. Next what? 1, 1. 1, 1. Obviously, it is so simple for you. AND operator says, if both the bits are 1, result is 1. Both the bits are 1, result is 1. any one of the bit is 0, result is 0. It is also called as a product rule. Which rule? Multiply 0 into 1, 1 into 0, 0 into 0, 1 into 1. That's it. It is also called what rule? Product rule. Come on, students. 0 and 1. 1 and 0. Yes. 0. Okay. Next, 0 into 0. Very good. 0. Next, 1 into 1. Yes. 0 now. 1. This is which rule? Product rule. Just remember. So, if I say product rule, you will say what is bitwise AND operator? You will say product rule, because student is always very danger. They will remember only the leaves concept, leaf level concept. Tree now, only leaves they will remember. Leaves means what? When heart is coming, leaves will go. But root is important for us. So learn root level concepts. Okay, now? So understand? So examples, very frequently asked written test questions, only bitwise operators. Of course, you don't feel it because of this. I did not see the student who answered perfectly in the written test, which I have seen in my 22, 23 years of papers, which I have seen in the companies when we were there in that. I did not see properly the student is answering. Maybe luckily ABCDs are there. If I ask one layman outside, 4 laymans, if I ask one layman, compulsory will answer correct only. What is there? He will keep his finger on one of the option. So luckily his luck is good, it is a correct answer. But if I am conducting a test, I will give fill in the blank. Fill in the blank is nothing but only powerful student only can answer. Come on, now I am saying A is 10, B is 15, and C is equal to what? A and B. Beautiful. A and B. A and B. Print of what? C. What is the answer I want to give you? Look at students. What is the value of A? 1 0 1 0. 1 0 1 0. What is the value of B, students? 1 1 1 1. 15 means what? 1 1 1. Understand? Okay. Come on, what is an operator you are applying? 0 1 1 1 0 1 1 1. Answer is what? 10. If I print C, what is an answer? S. And you don't ask me, sir, you said product rule 10 into 15 is equal to 150. No. Just a blind rule, people say it's a product rule. Understand? Yes. There is no formula for this type of thing. There is no formula. If you want, I can write that. Example 1, I will tell. Example 1, I will give the example number 1. Where I will use it, just for a minute, you give me, I will take up. A is equal to 10, B is equal to 15. Now see, students, C is equal to what? A ampersand B. Say, tell me now this is going to be like this. 1 0 1 0. B is going to contain what value here? 1 1 1 1 1. 1 1 1. Now this is going to contain what? Come on. I say this value is going to contain, this value is going to contain, come on, 1 0 1 0. Result is 10. Print C. Print of C. What is the result of C, ma? 10. 10. Now I will ask directly one more question here. One more question here. I can say print of directly 3 and then 4. 3 and 4. 3 and 4. If such things are given, 3 means what? You need to say 0 1 1. 4 means you need to say like this. Answer is what? 0 0 0. Answer is what? 0. AND operation now. Understand, guys? Fine. So print that 0. Print that 0. Print of 10 of 3. 10 of 3. Come on. 1 0 1 0. for 10, for 3, 0, 0, 1, 1. Please, 0, 0, 1, 0. Answer is 2 to the 0 now. 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. Answer is what? 2 only. 2 only. What you expect, that will not come. This rule is important. Okay. So take care of that. You must be so careful, and it's so different. It's not only in Python, it's like that. Even in C language also same to same. Are you okay, students? This is which operator? Which operator? Bitwise. Yes. Shall I go to the next term? One special case I will talk about it, ma. Special case I am talking. Where we can use it. We can use many of the cases in the programming I am going to use. One of the case, at this point of time, where I can use internally how it is useful to us. Come on, students. S1 is equal to 10, 20, 30. 10, 20, 30. S2 is equal to 40, 30, 50. 50. What are these called? Which data type? Which data type? Are you reading or not? Set data type this is. Okay. Now I will say S3 is equal to S1 dot intersection of S2. Intersection of S2. What is the value of S3? Print of S3. Print of S3. Answer please. Come on. 30. 30 is an answer. See how they are going to say? Just running the chart box like anything. Like that you need to say in the class. Say it is going to be what? 30. 30. Okay. Intersection already you know na? Yeah. Intersection will give you common element. You can say, my dear student, S4 is equal to S1 and S2. S1 and S2. Simple ma. Similar bits. Similar bits. Matching bits are going to be 1 now. Rest of them are zeros. Start. 30, 30 matching. 30, 30 matching. What is the result? So see that in detail how it is done. First, what is considered? 10. 10 and 40 ma. 10 and 40. What is going to be that? 10 is nothing but what it is going to be. First one you are considering 1, and this is going to be considered as 0 because it is not equal now. It is going to be called what? Next I am going to say 10 and what? 30. 10 and 30. What is that? Not, this is values are different. Next 10 and 50. 10 and 50 is called what? 0. That means there is no equality for the 10 in the next set. Next 20. 20 with 40. 20 with 40 is 0. 20 with 30 is 0. Now 20 with what? 50 0. 20 with 50 is 0. Next is called what? 30. 30 with 40 is called what? 30 with 40 is called what? 0. 30 with 30. 30 with 30 is called 1. That will be selected. 30 with 50 is a 0. Out of that 1 will be selected. That is nothing but what? 30 will come. So that is the internal comparison. Did you understand? Once again, last and final, how it is? What is the first element you are selecting? 10 means what? 1. Compare with all. 1 with 0, 1 with 0, 1 with 0. What is the answer? 0. 1 with 0, 1 with other thing, 0, 0. All these things are going to be called 0 only. Okay. Next 20. 20 means you are taking that 1. 1 with 0, 1 with 0, 1 with 0, 0. 30. 30 with 40, 0. 30 with 30, 1. 30 with 50, 0. 30, 30, 1. 30, got it. Next is called 40 with other elements, 0. 30 with other elements, 1. Already 30 was selected. 30 will not, next 30 will not come because it is a set allows only unique elements. Next 50 is called 1. 1 with all other elements not matching. 50 will not select. So I will print what here? Print of what, ma? S4. What is the answer, please? 30 will be the answer. Let us take these answers now. Let us take this question as a part of this. Yeah. What happens? So remove that. S2 is equal to 40, 30, 50. This is my examples, ma. Print of S1. Okay, directly I will write it. S3 is equal to S1 dot what? Intersection of what? S2 print of what? S3 30. Now say S4 is equal to what I am doing now? S1 S2 S1 and what? S2. Say this now. Print of what? S4. Answer is what? Like this. Like this you can apply. Understand? So how this is internally working, you are already aware of that. So take care of that. This is called the special case where you can use this kind of thing. Already this example I taught to you in the set only. We come across in the bitwise operators I said. Did you remember? Not remembering. We won't remember anything. We will not remember. When you remember why you will call student, you will be called as developer. But I remember everything. So where I taught, if it is there in your system, 9 a.m. data types. I hope it was there in my system. I think so. Data types. Data types is started in the online. I hope it was there in my home mission. That time only data types was started. So if you open your notes, it was available in your notes. Take care of that. Shall I go to the next one? Yes. Next one is called what? Bitwise OR operator. Yes. Very, very important. Bitwise OR operator, I will take it. See that, students? Fourth operator, bitwise OR operator. So simple, you can understand this one like this. So coming to that, bitwise OR operator, functionality of bitwise OR operator expressed with the following truth table. This is something like what you know, previous one is product rule. This is called a sum rule. Which rule? Addition rule. Start. OR means what? Any one of the bits are 1, result is 1. Both the bits are 0, result is what? Start. 0 plus 1. Yes. 0 or 1. 1. 1 or 0. Okay. 0 or 0. Okay. 1 or 1. 1 or 1, 2. Okay. Some you are doing. Okay. So that's why I don't want to tell that blind rules for you. Some rule means R said that some rule 1 plus 1 is equal to 2. Dangerous. Definitely they will ask you who is your faculty. Don't tell my name, please. 1 or 1. 1. 1 or 1. Either pencil or pen. Either pencil or pen. Any one of it. 1 or 1. 1. 1 or 0. 1. 0 or 0. 0. Why 1 or 0? You will take 1 or 0 now. I'll take 1. So there are a lot of ways. These are called on and off states. They are called on and off states. So my dear students, when you say 1 plus 1, I'm getting really a big shake. 1 plus 1 or 1 is, if you say 2 means what can I say? I don't have any answer for it. Please. So come to the students. This is called what? Truth table for it. Coming to the example section here. Example part. Okay, I forget to write the syntax, ma. Of course, syntax I will write it. Here only I will write syntax. Syntax is what? Variable name is equal to, come on, value 1 and value 2. Value 1, value 2. I'll take the syntax here also. This is called what, ma? OR. Truth table, you know. Example part, I will go for it. Example part, I will consider. Let us come to this point here. I will take it. A is equal to 10. B is equal to something like a 7. And C is equal to A or B. Okay. Come on, please. Okay, done. Before pressing enter key of 7, I will go for the calculation. What is that, ma? 1, 0, 1, 0. 7, please. 0. Okay. 2 to the power of 0, 2 to the power of 1, 2 square. 2 square, correct. 4, 2, 6 plus what? Right. So, 2, because I have to show you, otherwise you are out from the field. 2, 3, next is called what? 2, 1, like this. So, 1 is coming like this. So, you understand this part. Let us go back to this area, ma. Let us go back to this area once again. It's going to be. So, 1, 0, 1, 0. 0, 1, 1, 1. Say what? 1, 1, 1, 1. What is the answer? 15. And by mistake, if you say 17 means we will be out. Like 1 plus 1 is equal to 2. Very dangerous. How is the answer? 15. Now next, please. 3 and 4. 3 and 4. 3 and 4. 3 or 4. 3 or 4. You will get 7. 0, 1, 1. 1, 0, 0. 1, 1, 1. Answer is what? And luckily 3 plus 4 is also 7. And you don't ask me, sir, 3 and 4, 7 came, na? 10 plus 7, 17, so why it won't come? That is not a correct doubt. It depends on the bits you need to do it. Understand, students? Fine. So like that we can do the calculation part of this. So I can go to this place, I can do this calculation. So last and finally, if at all you want to do it, in this case, if at all you want to do it for a bits category like this, 0, 1, 0, 1, 0. Next 7, I will go for it. 7, I will take the 7. 7 is what, ma? 0, 1, 1, 1. I say this part of it. I say this part of it. I say, what is this? 1, 1, 1, 1. Whose result is what? Result is 15. Print of C, I got this result. 3 and 4, I got this. So I got this result. Okay, students? Fine. Easy or difficult? Easy. Not a difficult at all. Let us go to the next operator. What is the next operator, please? So I'll go to next operator. I have complement operator is there. Complement operator. Actually, I'll give a biggest discussion on it. There, I can give you around 1.5 hour. 1 hour, 1.5 hour is what? 2 hours lecture also I can give it on this operator. But you don't need that operator that much explanation. I can give you one small formula for you. Plus how it is working also internally I will give you. Why I said 2 hours explanation is because internally our NOT gates are also present. NOT gates, some gates internal operation how they are present. 2's complement, 1's complement, 9's complement, 10's complement. A big headache concept is there. That concept I am telling to you as a programmer, least bother about it. Because what is useful, you learn it. 1947 total story not necessary, because you are not going to enter into the chip level design programmer. Will you go for manufacturing sector? We never. And we never get an opportunity to work at the chip level unless and until you will become a VLSI developer or something like an embedded system programmer. And we never enter into that area, never bother about that. Let us coming to that. One point you remember. I say A is equal to what, ma? 13. 13. Now I am saying B is equal to tilde operator of A. Most of the people are not aware of that. Print of what? B. Print of B. What is the value of B? No problem. Whatever the knowledge is there, you tell me. I want to see that. I know you will say something. Come on. Good. Raise the hand. Raise the hand. Okay. Wrong answer. B. B. Minus 14. Minus 14. Anybody? Anybody? I'm taking other help. So I will suspense. Decision is suspense. For 1 minute, I will tell you. Next, C, I'm saying minus 13. Anybody else minus 13? Say minus 13. D, none of the above. Your answer. Silence is an answer. Silence. Silence is an answer. Option D, yeah? Option D? Option C? Raise the hands. Option C. Raising the hand. Wrong answer. Silence is also wrong answer. It is a very dangerous. Silence is a dangerous in the class. So answer is like this. So what is the formula I can give straightforward? Whenever any type of complement of operator is given, you say minus of a plus 1, you say. Minus of a plus 1. Minus of what is the value of a? 13 plus what? 1, which is called what? Minus 14 is an answer. Minus 14 is an answer. Print that here. Minus 14 is an answer. Complement means a lot of people will say that when 13, minus 13 is, they will select automatically. To get minus 13, I can apply minus operator. Na? Am I correct? So how this is working? I'll just say obtaining the complement of the given number. So that word itself is called very dangerous. Look at that. Syntax, I will write it. Syntax, I will write it. Variable name is equal to complement of value. So this operator obtains complement of the given number. What is that number? Working functionality. Let us take example part. Through example, I will give you the clarity. So now I am saying A is equal to 10 and B is equal to tilde operator of A. Okay, as far as this is concerned, binary number is called what? 1010. And as far as this is concerned, when this is applied internally, do you know what is happening? Complement of, I am writing 1010, you know, added 1 for that. Because one's complement, two's complement, if I go to that, 0 become 1, 1 will become 0, the total big story is there. At present, need not to worry about it. If at all you want, I will take some special part on it, we'll discuss. So it is nothing but what it is internally happening, which is equal to complement operator is nothing but internally considered as what you know. The moment when you add it, it is going to be taken as minus of. It is taken 1010. For that 1 is added. 1 is added means 001 is added. 1 is added. Then it is going to become what? You know, minus of. What is that operator is applied? You see, this 1, first 1, 0. This both of them will be added. How much is that? 1. Next 0, 0. Next 0. Next 1, 0. 1, 0, 1. Which is equal to what? Minus 11 is an answer. Are you getting? So it is going to be applied OR operator internally. 1, 0, 1, 1 is applied. What is an output here? Result is minus 11. Are you getting? So this is the way how you can go for it. One more I will take it. A is equal to 15. A is equal to 15. I'll say directly B is equal to tilde operator of what? A. Internally what is taken up? tilde operator of 1111 plus 1 is added. 1 is added, which is nothing but what? Minus of 1111 is adding with what? 0, 0, 0, 1, which is going to become what? Which is equal to binary addition is taken place. Binary addition. So you may say simply according to my explanation, it will be like this. Because of that, what is happening? It will become what? 15 only it will become. Am I correct? So for that, what is happening, students understand this part here. Okay. Now you see 1, 1, 1, 1, 1 is done. It is going to be 1 and 1, 1 with 0. Carry. 1, 0. 1 and 1 is going to be 1 with 0. That 1 is coming on, that 1 will go there, and this one. This is called binary addition, we can call. And 1, 1 again, it is going to be 1, 0. And 1 and 1 is called 1 and then 0. And this is going to be 1 with 0. And this is an answer. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Answer is what? 16. And previously, if you want to take it 1, 0, 1, 0, 1, 0, 1, 0 for a previous one, if you add this one, 0 and 1 is 1 only. 1 and 1 is 1 with 0 carry. Right. Next is called this one. And this is nothing but 0 only available. So this is called 1, 0, 1, 0. This is becoming like that. But it is in this case 1 and 1, 1 with 0 carry, 1 and 1, 1 with 0 carry, and 1 and 1, 1 with 0 carry, 1 with 0 carry. This is an answer is called 16. So I hope that it is going to become like this. Whose result is what? Of course, minus is applied. So result is, of course, 1 is there, ma. Result is what? Minus 16. Go for that. A is equal to 15. B is equal to tilde of this, print of B, which is going to become minus 16. If anybody asks that binary addition kind of thing, sir, why all these things difficulty, sir? Minus of A plus 1, you say. Simply. What is that minus of A plus 1? 15 plus 1, which is called what? Minus 16. Minus 16 is the result. Understand this? Suppose A is equal to 345. Directly I will print it. Complement of A. What is the answer? Minus 346. Simple formula. Are you following? So, coming to this point of this, I hope that this is done. In this case, 13 and 14 is done. And the 16 is also done. 16 is also done. And other kind of values are like this. So coming to this, and B of printer, of course, that is already there. So 345, the answer is like this. The data is like this. And out of this, as finished. So this is comes under what operator? Bitwise complement operator. Now let me go to the next operator, that is called what XOR operator. I will explain. Shall I explain today, tomorrow? Students, are you following, students? Soundarya, A not B, not like that, ma. That is a formula. A not B, no. A minus B, no. Right? Coming to that. So in tomorrow's class, it is similar to what? Even in C programming also. If these beginning only I told you. What is that beginning sentence I said? In the beginning operator only I said. These operators will be similar. These operators will be similar in all the languages I said. So never differs from one language to what? Another language. In all the languages, this will be continued. So tomorrow class, I will go for what? Left shift up. This is called what? XOR operator, I will explain. XOR operator, I will explain. Okay. And one thing you have to notice it, All these things are working on positive values. Negative values also, there is some other mechanism I will tell you. Negative values mechanism is also going to explain. This is working on positives, these formulas are. This is for positives only. For negatives, I will explain one more way of explanation for you. Same thing, only one small hint I will give you. Okay, na? This is working only on positives. Negatives, no. I will explain negatives, some other kind of description for it. Okay, at present, understand about this bitwise operators. Even in any website, if you see, any website, you just search in entire today, entire net, 24 hours you search, they will explain only positive numbers. They will not talk about the negative number. Even if anybody says negative number, they don't give explanation, but I will explain to you. Don't worry, at present, I will give in an appropriate, in my batch, everything I will cover. But give me an ample of time to discuss that. Okay, now? So let us go to the tomorrow's class. I'll go for which operator? Operator called what? XOR I will explain. So don't miss it. Tomorrow is an important session. Right. Up to here, I will upload. Tomorrow after I discuss, once again I will upload with which operator? XOR operator I will explain. Okay, students. Thank you. Good day. All the best. Yes, ma. Vamsi Krishna. 1 minute, ma. All of you, just to sit 1 minute. Vamsi Krishna is asking bitwise complement operator for minus 16. Simple, nama. I told you the formula. 1 minute, all of you. Minus 16. 1 minute. A is equal to minus 16. This is very easy. B is equal to complement of what? A. Tell me the formula. Apply minus of A plus 1. Minus of, what is the value of A? Minus 16 plus 1 minus of minus 15. What is the value is going to be? 15. Minus into minus 15 plus. Simple. Print what? B. 15 converted back minus 16 only.